make that decision early. So once we hit the load balancer, the balancer basically is going to hit something that we call request dispatchers. So it's basically we've got sort of an army of Tomcat servers just sitting out there. And one of the Tomcat servers basically is going to take the request and sort of walk it through to completion. So the first thing that's going to happen, all of our API requests have sort of a unique key. And the first thing they're going to do is they're going to hit the big cache, which is basically an army of memcached servers. And they're going to take the key that gets sent, and they're going to check to see if it's already in the big cache. So this is basically, for those of you who don't know, memcached, memory-based, in-memory key value pair lookup. Really, really fast. So it's going to check. So let's think about sort of a request that I'm going to show you in a second, which is an entity tagging request. Entity tagging is like you've got a document, a URL, a body of text, you want to get back all the entities in it. And so the first thing that's going to happen is, so that in that case the URL, pretty much, it's a little bit more detailed than that, but is the key. The request dispatcher is going to hit the cache and say, hey, do you already have this result? If so, we're out in less than a few milliseconds. And so incredibly fast response time. If you're building anything on the web, the vast majority of your stuff should be coming from in-memory, key value, simple, fast lookup. If not, then the request dispatcher is going to go hit lookup service. And lookup service is basically a cloud of fault-tolerant services. We're built on top of, I don't know if some of you, none of you guys are probably old-timers here, but Genie is a technology that Sun put out a number of years ago. We sort of forked off that a while back and have sort of souped it up quite a bit. But it's quite robust and works well for us. The lookup service, all it does is it keeps track of all of the hundreds of remote services that are out there. So every different type of our service, they're just remote components that kind of come and go into the cloud. And so we're operating, across a lot of machines. Stuff goes wrong, disks go bad, procs die, stuff happens. And when they die, the lookup service keeps track of the fact that they're no longer there. And when new services need to be brought online because we're scaling up, or we suddenly need, a few hundred more entity taggers, then we can just, fire up a few hundred more. They all register with the cloud. They're there. So the request dispatcher says, hey, I need an entity tagger. Lookup service says, hey, there's your entity tagger. It's over there. Here's its address. Goes to the tagger, gives its doc. Entity tagger does its work, gives them the results, shoves it in the big cache, so that next time it's available, sends the results back. Not in a few milliseconds, but still well below sub-second. It's something that we continuously optimize. So with that, I'm going to kind of jump in and sort of start demoing some product, the actual kind of commercial side product. So here we're launched on a number of different large publishers, and one of the publishers we're launched on is the Washington Post. So any new article that gets published in the Washington Post, this one's all about sort of Obama creating a task force to fight financial crime. The reader's sort of reading this, and they're in sort of a particular mindset. Down here in the lower left corner, all of this information here, this is all sort of Every powered. And so I mentioned, one of our core use cases is given a document or some text, give me a bunch of recommendations. And so here we see that one of the recommendations are the top entities that are in that text. The other one down here is the actual articles coming from the Post. So this is a strong value add for the publisher in this case, because the Post gets a chance for not just this article to get exposed to 3 other articles, but they're exposing their users to a lot of back-end content, back catalog content that they might click off and then go consume. Because it's not just this particular one. I might click on a particular entity here, in this case Bernie Madoff. I'm now not just getting related articles based on this article, but I'm getting those with a focus on Bernie Madoff. If I click on London, I'm getting updated results, and now I've got results with a bit of a British bent to them. So finally, it helps us out because some of these users are going to go ahead and find out, they want to find out more information, in this case about Bernie Madoff. So they click on Bernie Madoff, and they get sent to a fully dynamically generated and automatically generated topic page. So in this case, I'll kind of walk you through some of the pieces. These pieces here, business person, money manager, these are coming from the knowledge base. They're sort of high-level categorizations. And then here we've got sort of a relationship graph. And this is how Bernie Madoff is connected at this instant in time to other entities on the entity web. And can anyone tell me what query I would need to exit, and how I generate this graph? Does anyone have a guess based on what they've learned so far? Well, I'll show you. If you go back to this really geeky interface, I can search for something like this, which is basically just saying, give me all things that are connected to Bernard Madoff at the grammatical clause level right now. And so we see like there's sort of a bunch of stuff connected to him. And then we can basically hold a popularity contest against it and maybe do some balancing across different types of things. And based on that, then we can generate a graph like that. So one of the key takeaways is these relationships that we sort of hone in on, sort of the classic every Tinker Toy, are not static relationships. They're relationships that are continuously being updated like at any minute. So tomorrow, if Bernie Madoff is sort of mentioned as eating like an awful lot of hamburgers for, I don't know, whatever reason, and like everyone in the press is talking about it, then hamburger is going to show up here shortly after that spike happens. The other thing that we see is this trend data, and so as I mentioned, so it looks like about 5 days ago, 6 days ago, there was a big spike, and it looks like the spike had to do with money laundering, whacker drive. Okay. I don't know what it had to do with. It looks like, yeah. So in most cases, it's about a particular thing. Let's see. So the day after, there's a bunch of activity about 2 programmers arrested for roles in his Ponzi scheme. So be careful as programmers. Don't partake in someone else's Ponzi scheme. Probably don't want to partake in your own either. Other data, so as you can see here, we are able to pivot off of a lot of different media types. So we've got sort of tweets, images, quotes, videos. I'm going to go ahead and show you a little bit of the disambiguation in action. So, we've got over 40 different things called Blue, so we'll go ahead and go to one of our many entities called Blue. This is based on a forthcoming Bollywood film, Blue. I think what's most important about this page to understand is what's not on this page. So what's not on this page is anything about Joni Mitchell's album Blue, or anything about the British boy band Blue. So if you look down here, the related entities are all about this Blue. The title, the key articles, all of the articles are about this Blue. If we look, we also are looking at Twitter tweets. So all these Twitter tweets are also about this movie Blue. So again, you can sort of start to understand how we're doing this. We're leveraging a lot of that knowledge information. So we're doing things like, in this case, noticing that, well, Blue's kind of an ambiguous thing. If it's something that's not ambiguous, like Barack Obama's not really that ambiguous. Pretty unique set of characters that compose his name. Blue, pretty ambiguous. So that sort of gives us one clue. The other clue is, we might say, well, we know it's a film. So in the case of a film, maybe we do something like throw in the director's name or throw in some starring actors or actresses. On the indexing side, we can sort of look at a lot of statistical probabilities of sort of co-occurring terms based on this particular film, based on the fact that it is a film, etc. The other thing that you can see from these Twitter tweets that we're indexing, we're also identifying entities inside there. So that kind of fosters a little bit more encouragement. So here we see like the actor Akshay Kumar is, if we click on him, we'll go off to his page. We see Brad Pitt and a number of other things kind of mentioned. So I'll also show you so that these images here, just to show that we're disambiguating effectively, are also not about Joni Mitchell or any of the other Blues. And also the videos, I mentioned that we were searching other, so in the case of videos, in the case of images, we search our own index as well as news. In case of tweets, we search Twitter. In case of videos, we're off hitting YouTube. But again, we're hitting YouTube with a query that gets us stuff about this film. So one last thing here, off in the right-hand corner, all this information that I'm showing you here, it's kind of hard to see the colors here, but all this info here is structured attributes, structured information coming out of that knowledge base. And so here we're just showing sort of attributes about the particular film, but we also in our API, you can sort of say, well, gee, what if I want to make a whole experience based on any film whose country of origin was India, published in 1973.